So today we're going to look at lesson 13-6, which is graphing tangent functions. And actually, tangent functions are the easiest ones to graph of all, as long as you remember a couple things. So let's start off by remembering that the unit circle has the following properties. So let's just put in our radian measure. So 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. And then let's look at our ordered pairs. So on this axis is 1, 0. And this axis is 0, 1. And on this axis is -1, 0. And finally here is 0, -1. And then if you recall, the x value is cosine, and the y value is your sine. So all of these are cosine and sine, cosine and sine, cosine and sine. And the reason why I'm bringing this up is, remember that tangent of theta is equal to sine of theta over cosine of theta. Remember, that's y over x, so sine over cosine. I know that tangent is always opposite over adjacent, but when we're looking at ordered pairs, this is a basic ratio that's equivalent to tangent that you need to know. And I proved that with the special right triangles several lessons ago. So I'm not going to go over that again, so take this on faith that tangent is a sine over the cosine. So if you look and try, and since all of these ordered pairs have zeros in them, when cosine has a value of 0, tangent is going to be undefined because you cannot have 0 in the denominator of a fraction. So which of these axis points is cosine 0? Cosine is 0 here at 3 pi over 2 and at pi over 2. So right here and right here is where tangent is undefined. And this is important because it creates asymptotes in the tangent graph. And another odd thing, I wasn't in charge of the math world, but somebody decided that instead of going from like pi over 2 to 3 pi over 2 on the unit circle and laying our asymptotes at pi over 2 and at 3 pi over 2 and having this distance from pi over 2 to 3 pi over 2 be one period of tangent, that we were going to actually go in this direction. So we'll take this quarter or this quadrant up to pi over 2. And if we go backwards to this quadrant, remember, if we go backwards clockwise, we get negative measures, radian measures. So another value, or a coterminal value to the radian measure of 3 pi over 2 is negative pi over 2. Because if I go in this direction, that's negative pi over 2. So we are going to put an asymptote at negative pi over 2 because that's what's generally accepted as the parent function asymptote for tangent. And then we're going to go in this direction and put an asymptote at pi over 2. These are places where tangent cannot cross because it is undefined. So as we try to unwrap this unit circle that's around here and put it into this tangent function, we have to like leap over these two axes because tangent is actually not defined there. So again, you can see from here to here is 1 whole pi, and from here to here is 1 whole pi. And as you look at the number line here, from negative 1/2 pi to positive 1/2 pi, that is 1 pi. So your normal period for tangent is considered a pi. So it's not 2 pi like sine and cosine was. And then your amplitude, which is how high or how low tangent goes, that is also going to be undefined because here's what the graph looks like. So there is no amplitude. you're going to see it in the, you're going to see the amplitude in front of the function, but it will have no effect really on the curve itself. So here's what we're going to end up doing. All right, tangent, you've got to remember, starts high and on the right and goes down low and on the left. So it looks like this S-shaped curve with this point in the middle. That's the shape of the tangent curve. And so look at the distance between these two asymptotes and cut it in half. And so since it's a distance of 4 grid lines, halfway in between would be the origin right here. So I'm going to plot a point at the origin, and then all we have to do is let the asymptotes give our shape to the graph. So we're going to start up here, close to the asymptote, go through that point, and come back over here and approach the asymptotes, but not touch them. So that is one period of tangent. And then all you have to do is space your next set of asymptotes. So if these are 4 units apart, the next set are going to be 4 units. So 1, 2, 3, 4. So we're going to put another one here at 3 pi over 2. So you're going to see that you're going to have an asymptote at every pi over 2, right? So I'm going to put in, maybe I'll use green for the rest of my asymptotes. So here's my next asymptote. And then we've run out of room here. I mean, technically, I guess I could put an asymptote just like 1 grid line off the graph if it were here. So I'll put it here just so we can look at it. And then on the left, if you count 4 to the left, 1, 2, 3, 4, you're at negative 3 pi over 2. And then I'm going to count 4 more. So 1, 2, 3, and then 4. I'm going to put one just slightly off here so we can have our full periods. And then I'm going to put a point in the very center in between each of these sets of asymptotes, because that is where my line's going to go through. All right, and then finally, let's see. I'm going to use an orange line. So I'm going to go from the right to the left, put arrows on the end, because these lines go on infinitely. From the right to the left. From the right to the left. And from the right to the left. So the only thing that you have to worry about is what happens when the period of tangent changes, because that period is going to stretch out the distance between these asymptotes or shrink them. And so this is your parent function for tangent. This A is technically your amplitude, but it's going to have no effect because, as you can see, these graphs go up infinitely and down infinitely. So we really just kind of ignore anything that's in front of the tangent function. Whatever is happening to theta, that's what's going to affect your asymptotes. So I'm going to ignore all of this here because I don't find my asymptotes this way. So we're going to cross this out because I do it a different way. And it's actually really easy. If you remember that your original asymptotes, so let's go ahead and write out what our original asymptotes are over here. So let's maybe put up here asymptote. So let's circle this. And originally your asymptotes are at, let's say theta does not equal, because that's going to be an asymptote, pi over 2, because theta is undefined. That's kind of what I'm trying to say. And then theta does not equal negative pi over 2. These are your 2 original asymptotes, and they're going to be very important that you remember those. If you can remember these 2 asymptotes, then finding your period is going to be a piece of cake. So here we go. We're going to find our period a little differently. So the first thing we're going to do, I'm going to move this over a little bit so I can write on the left. Since nothing is happening to theta, it is your normal period of tangent. So our normal period of tangent is pi. And if that's the case, then we're just going to set up our asymptotes just as we did in the parent function. Now I know that we have a 2 in front, but that 2 actually has no bearing on the problem at all. It's going to look identical to what we just drew. So here's my original asymptotes. And then my point directly in the center on the x-axis, and then a curve from the right down to the left, and that's it. So y equals 2 tangent of theta, it looks no different than y equals tangent of theta. All right, because this 2 here really has no effect on the graph. And so then I'm going to go ahead and put in the rest of the asymptotes at 4 units apart, or 4 grid lines, which are all going to be at the 3 pi's over 2. And then I'm not going to put in the far right one, but I'll show you what I'm going to do if I'm not going to put that in there. So then here's this one. Okay, so then for my others, here's my point in the middle. I'm going to go from the far right down to the left. And then here, this would be my center, because remember, even though I don't have this asymptote over here, there would be 4, a distance of 4, and half of that is 2. So I'm going to estimate where this is coming from, so it comes a little shorter. Whoops, I didn't like that. Let's try again. There we go. So that one's going to look like that. So when you don't get the full period over here, you can just do like a partial. And then let's finish off the other 2. Far right to the left. And then this would be 2 from the asymptote for far right down to the left. And that's it. So let's look at one that actually has a period change. So let's look at number 2. So for number 2, to find our period, we are going to take this entire thing right here, whatever's happening to theta, we're going to take that. All right, and so we have what I like to call a start. Whoops, that's not what I want. I like to call this a start and an end. Okay, so we're going to take 1/3 theta, and we're going to set it equal to 2 different values. And what we're going to do is set it equal to our 2 original asymptotes. And our 2 original asymptotes on the unit circle is -pi/2 and pi/2. So that's what we're going to set them equal to. -pi/2 and pi/2. I probably should have moved these apart just a little bit. Sorry. And then we're going to solve for theta algebraically. So algebraically, if there's a 1/3 here, I'm going to multiply both sides by the reciprocal, which is 3/1. 3/1, which I think I am, let's see, I don't know if I can erase this, but I'm sure going to try. Oh yeah, of course not. I'm just going to move this over. We'll try this again. So I'm going to do a start, and then I'll do an end down here because I was running into each other. All right, so 1/3 theta equals 1/3 theta equals, and we're solving for theta. So on this one, I want to set it equal to -pi/2 and regular pi/2. So my start is always going to, whatever's happening to theta is always going to be set equal to -pi/2 and +pi/2, always, no matter what. So then we're solving by multiplying both sides by the reciprocal of 1/3, which is 3/1, both equations. And so I end up with theta equaling 3pi/2 and theta equaling, that's a -3pi/2, and theta equaling regular 3pi/2. So that's how far apart our asymptotes are. Distance between asymptotes. And that's, I'm just going to abbreviate it. So we can find our period by counting. So let's go ahead and put these asymptotes on our graph. So one is going to be at negative 3 pi over 2, and one is at positive 3 pi over 2. So what you're going to do to find your period is actually count this distance. So this is, remember these grid lines are going by quarters, because from here, from 0 to here is 1/4 pi. That's 2/4 pi, which makes pi over 2. So you can either look at it as this is 1.5 pi, and that's 1.5 pi, which makes 3 pi, or you can just count 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4 reduces to 3. So our period is 3 pi, in case anybody's asking. Our center, our very center, is at the origin, which it always will until we have a right-left movement. And then we are going to go from the right through the center, and you can see how stretched this funky, weird S kind of shaped curve is. And that's it. I'm not going to do anything on the right. I mean, I guess best you could do is maybe showing that it's coming this way. And maybe showing that it's coming this way. I mean, that's as much as we can do for those other ones. I guess I should have an arrow on this end. That's an arrow. Okay, so let's try a different one. So let's look at this one. Again, the 1/2 in front of the tangent means nothing. We only care about the 2 pi. So let's find our asymptotes. So we have our start. So our start is going to be this 2 pi is going to equal, and then our end is going to be the 2 theta equals. And then our normal asymptotes for tangent are pi over 2. Nope, that's going to be negative pi over 2. That's our start. And then pi over 2 is our end. The reason why negative pi over 2 is our start is because it's on the left. And so we're going to divide by 2. And dividing by 2 is the same as multiplying by 1/2. So I'm going to multiply the right side by 1/2, which is the same as dividing by 2. So I'm going to do that to both equations. And so we get theta equals negative pi over 4. So that's one of our asymptotes. And then theta equals positive pi over 4. So what has happened is our period has shrunk quite a bit. Remember, these grid lines are going by pi over 4. So this is our first asymptote at negative pi over 4, and this is our second. So if you count, your period is 1/4, 2/4. 2/4 is the same as 1/2 pi, so it's pi over 2. And then our very center is right there. So then we're going to go high on the right, low on the left. So we're going to have a lot of these. So I'm going to just count 2 grid lines, and every 2 grid lines I'm going to put in asymptotes so that they're all the same width apart. And then on the left, same thing. Okay, and so then I'm going to put the point in the middle, right to left, and arrows. Point in the middle, right to left, arrows. Point in the middle, right to left, arrows. Point in the middle, right to left, arrows. And keep going. all the way. You have to fill out the graph all the way from right to left, no matter how much of a pain you think it is. You can actually make some beautiful artsy pictures with tangent graphs. Okay, and that's it. And so then let's look at the last one, which is going to be number 4. So for number 4, same thing. We're going to do our start and end because we have to find our asymptotes. Oh, did we find our? Yeah, we did find our period in the last one. So start. We're going to take whatever's happening to theta. So we're going to take 1/2 theta and set it equal. And then our end, we're going to take 1/2 theta and set it equal to our normal asymptote. So negative pi over 2 and pi over 2. And then we're going to solve for thetas. To solve for theta, we want to multiply by the reciprocal, which is 2/1, to both sides on both equations. Theta is equal to negative pi. So the 2's canceled on both sides, so the 2's cancel here and here, and then theta is equal to positive pi. I really like it when my asymptotes are far apart because then I have fewer things to have to graph. So I'm going to graph the left asymptote here at negative pi and the right at positive pi. So to determine the distance between your asymptotes, from negative pi to 0 is 1 pi, and from 0 to pi is 2 pi. So the period for this function is 2 pi. And then we're going to put our point directly in the middle between the two asymptotes and from the far right through the middle to the left. Okay? And so we're not going to be able to get any more asymptotes over here. No, because I have to have 8. So, but I can get half of my, half of this curve, I can get half of it over here because from this asymptote to here is 4 units. So 1, 2, 3, 4, that would be at 2 pi. So I'm going to put my middle there at 2 pi. So it means it must come from here down to the left. So it's going to look like that. And then over on this side, I'm going to count 1, 2, 3, 4, which puts me at negative 2 pi. And so from here, I'm going to go from the right, upper right, down. And so those partial graphs are going to look like that. And that's it. So you're going to practice, do a few problems for your homework, and come prepared with questions tomorrow.